What does that mean? Huh? We're not going to solve data. Okay, you might look at it, but just looking at it isn't enough. Okay, so we can say we can look at data, look at it, and what? And take information from it. Learn something about data. Okay, so you're going to learn something about the data that you collect. Okay, well, it talks about what kind of data can we analyze. When you guys think about analyzing data, what are some things that you could or you have analyzed in the past, or that you maybe have seen other people analyze? Okay, so the number of things that happen. Okay, so you can count a number of things. Okay, so maybe with that's one variable. The Cowboys going to the Super Bowl and winning the Super Bowl. Okay, so that's 5 times. Okay, if you didn't know. So how many times they won though? Oh, okay. So you can analyze. When I talk about one thing, just the Cowboys, that's one. So that's called univariate data. Okay. At univariate, one variable. Okay. Then we have bivariate data, which is going to mean what? 2 variables. Okay. The prefix bi means 2, and variate means variables. So 2 variables. Okay. Uni, that prefix means 1, and variate variables. So 1 variable, 2 variables. Okay. And then there's what is called categorical. Any idea of what categorical is? Different, how that's different than univariate and bivariate? Univariate and bivariate deal with numbers. Okay. Categorical is not going to have numbers. Okay. It's just going to talk about like a brand of shoes, maybe. Okay. So now we're talking like your Nike, Adidas, things like that. Categories rather than numbers. Okay. So first data that we're going to look at, we're going to make what's called a dot plot. You're going to make dot plots. It's one way of representing data. If I'm representing data, what am I doing? If I represent it. Oh, if I represent it. Okay, I might take the data that we have, I'm going to put it into a graph or a chart so that we can see something. And then when you see something, then you can analyze it and get information from it. Okay, so what we're going to do is we're going to make a dot plot of everyone's shoe size in here on the number line below. Okay, so girls, in order to get to a guy's shoe size, or no, that's the other way around. Guys, to get to the girl's shoe size, you got to, I believe you add 2 to your shoe size. I think that's correct. Okay? So, if your shoe size is like 4.5, that's fine. Tell us 4.5, we'll put a dot there. Okay, so we'll just start. Chelsea, you want to start? Tell us shoe size? Yep. Okay. Aaron? Tim? You take your number and add 2 to get girls' shoe size. Okay. Charlie? Let's just go up the rows so we can go faster. 12. Kim? There's no reason to be laughing. It's just the shoe size. Who cares? Caden? Good one. Rylan? Lauren? Okay, notice now there's a couple of them where we had 2. I just keep stacking them. Okay, so if we have another 13 and a half or we have another 7, I just keep stacking them. Okay, Sadia? Dylan? Evan? 11? Brody? JJ? Brooklyn? Alex? Dylan? 11? Okay. Jack? Hannah? Marsh? 10 and a half. Okay. So that's one way of, we just represented our data. Okay. Now, after representing your data, you can analyze it. And when you analyze it, you're going to learn something about it. Okay. So now we look down here, it says, what does the graph say about our shoe sizes in our class? The most common is 7. Okay. So that's one thing you can say. How many variables did we analyze in this? How many different variables did you analyze? No, that's how many data points we might have had, but how many different questions did I ask you? 1. Just what's your shoe size? So that's the only variable is shoe size. Okay, so just 1. Is there any? But it doesn't matter. I just asked shoe size. Okay, it doesn't matter, girl, boy. I asked shoe size. Okay, how about anything else the graph says? There's a few of them that are least common. Okay, our largest is 15, our smallest is 5, you could say. What's the range? Does anyone know what range is? It's 10, Alex. How is the range 10? Yeah. The highest minus the lowest is the range. Okay, so 15 minus 5 gives us a range of 10 different shoe sizes that we have in here. Okay, but really it's 10 different shoe size whole numbers, because if you include the halves, then now we got about 20 different shoe sizes in here. Okay, so those are some different things that you can learn about looking at a graph like that. Questions? Oh, you're right. I didn't put mine in there. I would have been 14 and a half would have been me. Okay? So, next we're gonna put our height in inches along with our shoe size. Okay, so we're gonna use the shoe size from the last graph and then our height in inches. Okay, how many inches are in a foot? 12. So if you're 5 foot, that's 5 times 12 is 60. So you can use that as a guideline. So maybe if you're 5'6", then you're 60 plus 6, and you're 66 inches, right? Okay, so I want you to figure out your height in inches for us, so that when I come around, you're going to give me, again, your shoe size again, and then your height. Okay, and then we're going to graph each one. 12 inches per foot. So 5 foot is 60, and then you add however many more you are than over 5 feet. So how tall are you? So you have 60 plus the 5, 65 inches. Okay? So we'll start again. Chelsea, you got your height? 67. And then what was your shoe size? 10 and a half. Okay. So your first one is going to be 10 and a half and 67. So 67 right about there. Okay? Aaron? And shoe size? So 7 and 65. Red one, we'll go here. 67 again, and your shoe size? 7.5 and 67. Okay, Kim? 6.5, 65. Okay, Tim? 13.5 shoe size? Okay. Okay. 12 and 68. Kaden? And shoe size? Okay. And 65. Alan? Mark? Sadia? Dylan? Okay. Evan? Brody? JJ? So we have another. Yep, that's all right. Brooklyn? 60. 7 and 60. Alex? Okay. And Dylan? Jack? Anna? And Marshall. Okay. So, how many variables? Two, because what are they this time? Shoe size and height. So there's two variables. Okay, so then we plot it. Can you analyze that? Do we have enough data to be able to analyze that? Yeah, we do. What can you say? Huh? Generally speaking, if you look at the graph as a whole, if I move from left to right, okay, what's happening? Slightly happening. Okay, slightly as the shoe sizes are increasing, the heights are increasing. Okay? And so that's one thing you could analyze. You would say as the shoe sizes increase, the heights increase. Okay? So let's write that down. Okay? Questions? Okay, very good. Okay, univariate data involves what? One what? Variable. Okay, involving I'm going to cross that out. I'm going to say involving one variable. Bivariate data? Two variables. Just one and two, and then categorical, which could have many different. Okay? Or it could just have one. Univariate. These are some things, okay, that we also are going to see about univariate data. Okay, there's no cause and effect. Where in bivariate, you're going to have cause and effect. One variable will probably cause the other. So if we look at this bivariate data, what variable causes the other to change? The shoe size. Causes what? The height to change. As the shoe size increases, the height is increasing. Okay? Is there any cause and effect here when you talk just shoe size? No. It's just because there's only one thing to talk about. So there's no cause and effect. Okay? When you're talking about univariate data, your major purpose is to describe that one thing, that one variable. And then when you talk about two variables, you want to explain the reason between the two variables. Why is something happening to one because of the other? Why is our height increasing when our shoe size increases? Okay? Okay, so that's what bivariate data is. You have to explain something. Okay, some of the different things you can find with univariate data. You've heard of mean, median, and mode. Range, the maximum and the minimum. Okay? And the sample question is how many students in the freshman class are female? And all you do is just count one thing. How many females in the freshman class? Okay? Different things that you're going to do with bivariate data. You're going to talk about independent, dependent variables. You're going to go back and look at linear relationships. Okay, we're going to probably make graphs and tables of these and find the relationship between the two variables. And then here's another example. There's a relationship between females in computer programming and their scores in math. Okay? You're looking for a reason as to why something is happening. Why is the Earth's temperature, average temperature, increasing over the past 10 years? Okay, those are things that you look at, right? Science uses this a lot. Okay? Categorical data. Okay? Now I'm not asking you numbers. I'm just asking you yes or no. Okay? So male, female, and then hair color, black, brown, blonde, red, or other. Yeah, because I want to see how many we've got. Okay? So Chelsea, blonde. Okay? Aaron? Kim? Good one? Rylan? Oops. Caden? Charlie? And all you're doing is just tallying them up. Kim? Dylan? Evan? Brody? Sadia? Lauren? Brown? JJ? I'm running out of room there in that one. Brooklyn? Alex? Blonde? Dylan? Blonde? Jack? Hannah? And Marshall? Brown? Another Brown? Okay. So, did I get numbers from you guys in that one? No, I just counted yes or no's. Okay, is your hair black? Well, no. Is your hair brown? No. Is your hair blonde? Yes. Okay, so then that's when I put my tally mark. Okay, so categorical is just kind of to see yes or no to the different things that I present you. Okay, so another categorical question is, okay, do you have a pet? And do you have to do chores? Yes. Okay, so I can do two things. do you have a pet and do you have chores? So you'd have to answer yes or no to both of them, and then I can find, okay, if you have a pet, do you have chores usually? Or if you don't have a pet, do you not have chores now? It's something that you can look at and learn about, okay? And then they want us to find totals. So they want us to find totals for both the columns and the rows. What's a row and what's a column? Okay. Columns go up and down. Rows go left and right. Okay. So total female. We count 1, 2, 7, 9. Total male. 1, 2, 3, 4, 5, 6, and 5, 11. Okay. How many total with black hair? 3. Total with brown hair? 13. And total with blonde hair? Now, you're going to get, at the end, a grand total. What's 9 plus 11? 20. And what is 3 plus 13 plus 4? They should both equal what? The same number. If they don't, then we counted wrong somewhere. Okay? 9 and 11 equal 20. 13, 3, and 4 equal 20. Okay? Questions? Okay. So we're going to go through these. I have these questions up here. You're going to tell me, is it numerical, meaning you're going to give me a number answer, or is it categorical where you're going to say yes or no to the answer? Okay? So how many pets do students in our class have? Are you going to give me a number answer or a yes or no answer? Number. So then that's numerical. I'm going to abbreviate NUM for numerical. Wherever you want. How many hours a week do we spend watching TV? What answer are you going to give me? You're going to give me a number answer. Numerical. I ask you how many hours do you spend watching TV in a week? That's a number you're going to give me, right? So that's numerical. Okay? What's your favorite sport? Okay, now you're not giving me a number, you're giving me a sport. So that's categorical. What kind of music do you like best? How many hours a week do we talk on the phone? What kind of snacks do we like? How much do our backpacks weigh? How much candy do we eat each week? Does our height affect our weight? Categorical. And does our gender affect our hair color? Okay. Now we're going to talk about univariate versus bivariate. How many pets do students have in our class? Is that one variable or two variables? One. All I'm talking about is number of pets. So it's univariate. Okay, how many hours do you spend watching TV each week? Univariate or bivariate? Just hours, right? So then univariate, one variable. What's your favorite sport? Univariate, it's one category. What kind of music do you like best? Univariate. How many hours do we talk on the phone? Univariate. What kind of snacks do you like? Univariate. How much do your backpacks weigh? How much candy do you eat each week? Height and weight. Okay, bivariate. Gender and hair color. Bivariate. Okay, very good. Today you're going to work on I1. It's not H anymore. I1 worksheet. Make sure you put your names on your notebooks and your workbooks. Yeah. That's correct.